7,000 years ago, the largest eruption in human history happened beneath the sea. We will follow the Jōmon people and what ended 14,000 years of civilization in a single morning. And we will ask one question that science has not yet answered. Is this how it begins again? You have heard of Krakatoa. 17,000 dead, 3 days of chaos. The Akahoya eruption was 32 times larger, and no one survived to describe it. Beneath the ocean, south of Japan, sits a caldera 9 miles across. It produced the most powerful volcanic event of the entire Holocene era, and in 2026, researchers confirmed it is filling with fresh magma from below. To understand Kikai, you need to understand what a caldera actually is. Most volcanoes erupt upward, lava, ash, a cone you can study and photograph. A caldera erupts so violently the entire chamber collapses inward, leaving a basin, not a peak. Kikai is one of these, 9 miles wide, sitting below 40 meters of Pacific water. It lies south of Kyushu, Japan's southernmost main island, in the Kagoshima prefecture. Most of it is invisible, a submerged ring of volcanic rock with no summit to photograph. Japan sits on the Ring of Fire, the most seismically active zone on Earth. The country records more than 1,500 earthquakes every year. This background of constant tremor is part of why Kikai went largely unnoticed. In a country where the ground always moves, one underwater depression didn't seem urgent. But geological urgency operates on a different timescale than human concern. 7,300 years is recent, in geological terms. And yet no one living above Kikai today was alive for the last eruption. The Jōmon people arrived in Japan roughly 14,000 years before the Common Era. They were hunter-gatherers, but that phrase barely covers what they had built. They produced pottery, the oldest fired clay vessels ever found, predating Chinese ceramics by thousands of years. They had trade networks stretching hundreds of kilometers along Japan's coastline. They had a stable population of roughly 250,000 people. Their name, Jōmon, means cord-marked, from the patterns pressed into wet clay before firing. They occupied the Japanese islands longer than any civilization that came after them. And here's where it gets complicated. On one morning, approximately 5,300 BCE, that ended. No one who witnessed the Akahoya eruption wrote anything down. What we know, we have reconstructed from ash layers preserved on the ocean floor. In the first minutes, the eruption expelled material at temperatures above 800 degrees Celsius. Pyroclastic surges crossed the ocean surface at 200 kilometers per hour. They reached land still hot enough to incinerate everything they touched. The volume expelled, 160 cubic kilometers of dense rock, is almost impossible to visualize. 32 times Pinatubo, the eruption that killed hundreds and dropped global temperatures by half a degree. Ash fell across 4,500 square kilometers of southern Japan. Pyroclastic flows reached 93 miles from the eruption's origin point. What survived the Akahoya eruption were not a culture, they were refugees. Archaeological records show Jōmon settlements on Kyushu disappear completely from the record after the eruption. Populations in southern Japan fell to levels from which they never fully recovered. The Jōmon lasted 14,000 years. After Kikai, they had centuries. By 300 BCE, agricultural migrants had largely replaced the surviving Jōmon population. A civilization that outlasted every ancient empire became a genetic trace in modern Japanese DNA. The caldera that produced all of this sits 9 miles wide below 40 meters of sea. For decades after it was identified, scientists classified Kikai as dormant. The assumption, held quietly, was that it was cooling, finished, past. In 2026, researchers at Kobe University published something that changed that assumption. Using seismic surveys across the seafloor, they mapped what sits beneath the caldera floor. What they found was a low-velocity anomaly, the acoustic signature of molten rock, a magma reservoir, sitting just 2.5 to 6 kilometers below the sea floor. That depth surprised the research team, shallower than their models had predicted. And here's where it gets complicated. The chemistry of the magma was more important than the depth. The magma in the reservoir is not leftover material from the 7,000-year-old eruption. It is newly injected, fresh melt rising from deep below the Earth's crust. What's worth sitting with here? This is not a system losing energy after an ancient event. It is an active system, receiving new material from below, actively recharging. Most accounts of this story stop at the discovery. Here is what they miss. No eruption timeline was offered alongside the research publication. No timeline was offered because none could be calculated. The caldera is not classified as an active emergency. It is classified as something harder to manage, a system that is working. Working is not the same thing as safe. Kikai is now studied alongside Yellowstone in the United States and Toba in Indonesia. None of those systems is considered imminent, and none of them is predictable. What they share, we can observe them recharging, but we cannot observe them stopping. The Jōmon had no way of knowing that pressure had been building beneath them. We have seismic surveys, deep ocean imaging, and low-velocity anomaly mapping. We have scientific tools they could not have imagined. We still do not know when. 60 to 75 words. Since the Kikai discovery, the question inside volcanology has shifted from whether to when. Not just for Kikai, but for the broader class of caldera supervolcanoes worldwide. The Toba supervolcano in Indonesia last erupted 74,000 years ago. That eruption may have reduced the entire human population to fewer than 10,000 individuals. The genetic bottleneck in human DNA from that period is documented and not disputed. Yellowstone last erupted 640,000 years ago. Its caldera is continuously monitored, sensors embedded across the entire Wyoming basin. No prediction of its next eruption is scientifically defensible. What Kikai adds to that picture is a confirmed refilling event. Scientists have now mapped a supervolcano mid-cycle, watching it build toward something. What they cannot map is the second half of that cycle. The 2026 Japan earthquake struck Kyushu, the same island chain that sits above Kikai. Seismologists did not connect that earthquake to the caldera system beneath the ocean. But it was a reminder of something the monitoring data makes easy to forget. This is an active geological system sitting beneath everyday life. Every instrument placed above these systems represents an acknowledgement. The acknowledgement is this: we do not fully know what the ground beneath us is doing. That was also true for the Jōmon at 5300 BCE. We now have the instruments to see the magma rising beneath us. The question science cannot yet answer: how much warning is enough? What the Kobe University study changed is not our sense of danger. It changed our sense of sequence. We now know which stage of the cycle we are watching. Refilling is the first act of an eruption cycle. It is not the last. What happens between those acts is what the data cannot tell us. The Jōmon built 14,000 years of civilization above a countdown they had no word for. Follow Elena, 2 new documentaries every week.